Hi guys, it's kind of late, so I'm just going to go over the problems that I had you guys do, and I think I'm going to call it a night. I was going to go ahead and give more notes, but I think I'm going to wait and do that tomorrow. So let me just go over the problems with you. Excuse me. Number 2. The driver of the compact car in the previous problem suddenly applies the brakes hard for 2 seconds. And as a result, an average force of 5 times 10 to the third newtons is exerted on the car to slow it down. A, what is the change in momentum? And remember, that's the same as asking what is the impulse and the change in direction on the car. Well, let's do that first, because that one's not as easy as it sounds. All right. So first of all, like I said, the change in momentum is just another way to ask what is the impulse on that car. And if you remember that the formula for impulse is simply force times the change in time. So that sounds simple. So we've got the force as 5 times 10 to the third newtons, and we've got the change in time, which is 2 seconds. So it's, and since we're braking, that force is being applied in the opposite direction. So you could write it 2 ways. 1 times 10 to the 4th newtons per second west, or you could simply write it negative 1.0 times 10 to the 4th newton seconds, and then we know that that's in the opposite direction. So down to my lovely sketches, because B asks us what? To complete the before and after sketches and to determine the momentum and the velocity of the car. Ugh. Okay, well, here we go. So here's my before. Look, I'm going east. And here's my after. I'm still going east, but my vector is smaller because I've applied the brakes. So the momentum, we got this from the previous problem that I did yesterday. And just as a review, you can find it in the video, or you can see it here. It's 2.32 times 10 to the 4th kilogram meters per second. So that was the momentum we found yesterday about that compact car. And now we need to find this momentum, and then we're also going to find the velocity. So here we found that this momentum is negative 1.0 times 10 to the 4th. So all we have to do is do the final minus the initial. So the final, I'm sorry, I got lost. So we're going to use impulse equals change in momentum, but we are going to switch this around so that we are finding just our final momentum. So we're going to switch this. We're going to add the initial momentum to each side. So then we're going to have force times change in time plus the initial momentum. And once you plug in your numbers, you'll see that it comes out to 1.3 times 10 to the 4th kilogram meters per second. And it's slower, but it is still going east. So let's look at the second part of that problem, which is finding the velocity. So in order to find the velocity, we have to switch around our problem. So you'll see that to find velocity, that you have P equals mv. But we need to find this. So here's what I did. I divided both sides by our mass, and then I have to divide this by the mass. So now I'm left with our final momentum divided by our mass, is equal to our final velocity. So we just take the numbers that we found here, our 1.3 times 10 to the 4th kilogram meters per second, divide that by the mass of the compact car, and what you'll come up with is 18 meters per second. And I'm sorry that I feel like I'm kind of in a daze here, so I'm sorry if some of this is a little bit choppy. Let me try to make the next one a lot smoother. Let's look at 3. A 7 kilogram object moving at 2 meters per second receives 2 impulses, one after the other, along the direction of its motion. Both of those impulses are illustrated in figure 2. So let's look here. So it looks like the first impulse hits it in the same direction, or in the positive direction of its velocity. And the force is 5 newtons. In the second one, it must be coming in the opposite direction because the force in the second collision is negative 5 newtons. And remember, it doesn't mean that it's less than 0. You can't have that. So the negative has to mean coming in the opposite direction of our moving object. So both of these impulses are illustrated. Find the resulting speed and direction of motion of the object after each impulse. Okay, so we start like we do with everything in physics. What do we know? We know that the mass, we know that the mass is 7.0 kilograms. We know that the first force is 5 newtons. The second force is negative 5 newtons. The initial velocity is 2 meters per second. So let's take a look at our time. The first impact, if you look at the little table here, the little graph, you'll see that the first impact happens at 1 second, and the second impact happens at the second. So 2 minus 1 leaves us with a change of time in 1 second. So what formula are we going to use? Well, we're going to use the impulse momentum theorem. So force times change in time is equal to the change in momentum. And you can break down the change of momentum into some of the things that we have here. And that is mass, and we have velocity. Well, we don't have final velocity. We only have initial velocity. So we're going to have to do some rearranging of this equation. Okay, so I'm going to set it up like this. Force times change in time is equal to the mass times final velocity minus the mass times initial velocity. Another way you could do that is simply m times VF minus VI. But I'm going to go ahead and do it the long way this first time. So let me plug in my numbers first. So before, don't look underneath yet. So the first thing I have is my force of 5 newtons. My change in time is 1 second. My mass doesn't change, it's 7 kilograms. Well, we don't know the final velocity. We're going to rearrange and solve for that. Minus 7 kilograms times the initial velocity, which is 2.0 meters per second. Well, the first thing I'm going to do is the easy part. I'm going to get rid of my mass. So I'm going to divide by 7 kilograms, and I have to do it the same here. So now, don't look at that yet. So now I have 5 newtons times 1 second divided by 7 kilograms. But that's not the only thing I have to do. So now I'm left over here with the final velocity minus 7 kilograms times 2.0 meters per second. Well, you know what? I'm going to get rid of this as like an entire bracket. So I'm going to leave that together and just add it to both sides. So now that cancels out. And I'm going to add this part to this side. And that's what you see here. So here's the clean version. Now you're left with your force times change in time plus your initial velocity times your mass divided by the mass. This will give you your final velocity. So once you calculate all of this, you are left with 2.7 meters per second in the direction of the original velocity. So, of course, if you hit something in its original direction, you're going to speed it up. So it went from 2 meters per second to 2.7 meters per second. Does that make sense? Absolutely. So we know we're at least in the right ballpark. And now we're going to do the same problem, but with a negative with a negative force in the opposite direction of the 5 newtons. So we're going to use negative 5 newtons. Remember, that doesn't mean it's less than 0. It's simply a force in the direction opposite the original motion. Okay? So let's set it up again. This will be your original formula. And we are going to rearrange to solve for final velocity. Well, this time I just rearranged it before I put in my numbers. It's easier for me to do that. And I know that some of you like to put in your numbers first. But for me, I like to rearrange. And I rearranged it exactly the way I did the last time. This will be your final formula to solve for VF. So now my force is negative 5 newtons. Here's the change in time. Here's the mass, the original velocity, divided by the mass. This time, once you plug in all these numbers and you calculate, you will find that you're still moving in the same direction, but now it's 1.3 meters per second in the direction of the original movement or in the original velocity. So yeah, it slowed down. Well, that makes sense. You're moving at 2 meters per second. Something hits you in the opposite direction. And did we slow down? Yes. So that number is smaller than 2.0. Good. And here's the way I look at it. That's a 7 kilogram ball. If we times that by gravity to get newtons, the force, the weight of this object would be almost 70 kilograms. And you're hitting it with a force of 5 kilograms. So yeah, it's not going to stop the ball. It's just going to slow it down. Okay, so that's how I know in my head we're on the right track. All right, let's do the next one. All right. The driver accelerates a 240 kilogram snowmobile, which results in a force being exerted that speeds up the snowmobile from 6 meters per second to 28 meters per second over a time interval of 60 seconds. So you guys need to do A, B, and C. The first thing we're going to do is sketch it. The second thing we'll do is we'll find the change in momentum. And remember, all that means is what is the impulse of the snowmobile. And then third, we're going to solve for the force. Yeah, of course we do. So we're going to do mass times the final velocity minus the initial velocity. So the mass is 240 kilograms. And then we're going to multiply that by 28 meters per second minus 6 meters per second. And once you do that, you'll come up with a momentum of 5.28 times 10 to the third kilogram meters per second. So with C, it is asking us to find the magnitude of the force that's exerted on the snowmobile. So I'm going to use the change in momentum, which is what we have here, is equal to the force times change in time. So let's rearrange to solve for force. And that's an easy switch. I'm going to divide both sides by time. So now I have change in momentum over change in time is equal to my force. Good. We need a nice simple problem. So we have 5.28 times 10 to the third divided by our 60 seconds. This will give us a force of 88 newtons. And that's it for the problems that I had you guys do. And I hope you guys have a wonderful evening. Tomorrow I'll go ahead and put up notes for section 2. So I'll get that sometime, probably in the afternoon. So tomorrow you'll just be kind of watching this and doing, rereading your problems or redoing your problems. Or maybe if you were really stuck on them, I sure hope this helped. Like I said, I know some of it was a little bit choppy. I know I'm tired right now. So let me know if you guys need more help. I will definitely explain things better for you. Thank you so much. You guys have a good day. Bye-bye.